All right, and welcome. What I'd like to do today is to go over setting up the LabVIEW data acquisition program to measure the output from a strain gauge. If you look at slide number 1, we have a series of images in the upper right-hand corner. Image A shows a strain gauge and its connector wires that have been attached to the end of a cantilever beam. Of course, for this exercise, we'll be using National Instruments LabVIEW as the data acquisition software. We will take our cantilever beam that we see in Figure A and place it into the rig that is in Figure C. We will go ahead and deflect the beam when it is in the rig, and from there we'll be able to take measurements using the LabVIEW data acquisition system. Figure D shows the module we'll be using, and last but not least, Figure E shows the carrier system. The module will connect into the carrier system, and the carrier system in Figure E will be sort of the doorway between what's going on with the hardware on the benchtop and the software we'll be using to collect the data. Our next slide in the series shows the connector part. Of course, if we're going to be using a strain gauge, we have to use a Wheatstone bridge. Fortunately, as we can see in Figure F, the strain gauge will be connected to the Wheatstone bridge. We'll use the quarter bridge configuration. In this case, R1, R2, and R3 are going to be constants at 120 ohm. The gauge itself is a 120 ohm gauge, but as its elongation and shape and size changes, we'll see a corresponding change in the resistance, from which we can glean some information about the strain on the cantilever beam. Please note that the Wheatstone bridge is incorporated into the module that is shown in Figure G. Each of the modules can hold or operate with up to 8 strain gauges, and the modules contain a small Wheatstone bridge that provides a configuration for the strain gauge. And slide 3 shows us the connections that we'll need to make with the strain gauge. Of course, the strain gauge is an electrical device, so we're going to have to provide it a little bit of power, some trickle current, and we'll also have to provide a output. We, of course, want to get strain data from this device. Looking in Figure H, I've shown the 3 connector wires. They're color-coded red, black, and white. And you can see them down here in Figure I, where they connect into the soldering tabs that link up to the strain gauge. Of course, you can almost see the circuit here. The black wire would contain the excitation or the power-up voltage. That would then go to the strain gauge, and from there, the electricity would then flow out of the gauge to the red and white wires. Of course, the red wire will be our signal output. The white wire will provide completion with the Wheatstone bridge that was previously mentioned. And where do the wires go? Well, just following from the previous slide, we can see that the black, white, and red wires are connected up to the module that is now housed in the carrier system. Again, the carrier system is going to serve as sort of the doorway between the hardware on the benchtop, the cantilever beam with its strain gauge, and of course the computer with the data acquisition software. If I look closely at the module, I can see that the black wire is providing power. That's the excitation. The white wire is our signal output. That's where we're going to be reading the strain. And of course, the red wire is providing bridge or circuit completion for our strain gauge. Moving on from the hardware connections, once we get everything set up and connected properly into the module, we can go ahead and run the software. For this example, what I'm showing is a deflection on the beam. So once we have the cantilever beam with its strain gauge mounted into the rig, we can go ahead and deflect the beam. And when we deflect the beam, its surface is either going to expand or contract a little bit. And we can see here on the graph those changes in the surface strain of the cantilever beam. So we push down, we see an increase in the tension, it goes up. we release it, we see a decrease in the tension going back to the lowest point there. We can do that over and over again, just sort of to test out how well our gauge is functioning and whether or not we're getting an appropriate response from the data acquisition system. At any rate, this is an overview of how to connect the strain gauge to the computer and then to run the software to get some information from our experiment. Thank you very much.